Hi friends, failure is life's best teacher. Two objects are connected by an ideal, massless rope, as shown in the figure. The rope and pulley are massless and frictionless. Now, we are asked to determine the horizontal force that must be applied to an object of mass m1 to keep the system of objects from moving. Before we go any further, let's take a quick look at this animation. The block on the side of the inclined surface will pull on the block on the horizontal surface. This is because all contact surfaces are frictionless. To maintain the system in equilibrium, a horizontal force must be applied to the block on the horizontal surface. This is the force we want to calculate. How about identifying each object? This block is block 1. This block is block 2. This is important so we know the physical quantities acting on the blocks. Blocks move because of forces. Objects with mass near the Earth's surface are affected by the pull of gravity. Both blocks experience a vertical downward gravitational force. The blocks do not penetrate the surface, meaning there is a normal force. The rope connected to the blocks also exerts tension in the rope in the direction of the rope. Of course, the horizontal force on block 1 is F1. Several forces acting on the same object have a resultant force. For block 1, it tends to move horizontally. T minus F1 equals M1A. Block 1 does not move vertically, N1 minus M1G equals 0. For block 2, it tends to move in the direction of the inclined surface. However, the direction of the gravitational force is not in that direction. We can resolve the gravitational force into its component vectors. The resultant force in the direction of motion, m2g sine theta minus t, equals m2a. The resultant force in the normal direction, n2 minus m2g cosine theta equals 0. Because the surface is smooth, there is no friction. What if we ignore the normal force? Since friction is affected by the normal force, friction is absent here. Now we have two equations of motion. The force on block 1 is applied to keep the system in equilibrium. The system is kept at rest. The acceleration of the system is 0. Add these two equations to eliminate the tension in the string. From here, F1 equals m2g sine theta. At this point, we can see some values on the worksheet. The mass of block 2 is 10 kilograms. The acceleration due to gravity is 9.8 meters per second squared. The sine of 30 degrees is half. This calculation is quite simple. F1 is approximately 49 newtons. Written as a decimal, the answer is 49.0 newtons. Happy learning, everyone!